Afternoon everyone, I'm Steve Smith from Mazak, just down the road in Worcester there. They've given me my full name on the agenda, so I feel like I'm going to get told off at some point. It's only my mum calls me Stephen. Who are we? Just briefly, for those that don't know what we do, we're a family-owned company. The Yamazaki family own us over in Japan, and from their name we take our brand, the Mazak brand, and the company name of Yamazaki Mazak, of which we are Yamazaki Mazak UK. We were founded back in 1919 by Mr. Sadakichi Yamazaki. He founded the company primarily to make straw mat weaving machines, and in 1927 he decided he was going to venture into the world of machine tools, and they started selling their first commercial machine tools, which were lathes at the time. We are a worldwide company. We ventured outside of Japan in 1974. We've got 11 manufacturing sites across the world, 5 in Japan, 2 in China, there's 1 in Singapore, 1 in Kentucky in America. We've got more recently India, and then there's us sat in the middle there, just down at Worcester. We're also the European headquarters for Mazak, so we look after Mazak's operations throughout Europe from that site. Now, because of the business that we're in, machine tools, they're widely regarded as being known as mother machines because of the things that they make. Because of which we tend to be in pretty much all industry sectors. Anywhere that metal needs to be cut, you'll probably find us. Aerospace is a pretty big industry at the moment. Since COVID times, medical and healthcare has risen as well. Energy generation, we seem to be moving more from the traditional oil and gas into renewables, but nonetheless still a very buoyant market. As I mentioned, we're just down the road in Worcester. We've got a site down there, round about 650 employees at any one time, manufacturing and assembling the machine tools down there. We've also got design engineering in-house. There's a couple of very successful product lines that were both designed and manufactured entirely at Worcester. We also house our service department down there, although we've got field engineers throughout the country. They're coordinated from Worcester. Got our applications department down there, and so far to date we've produced over 30,000 machine tools from the plant in Worcester. It's a continually evolving and continually growing place. We started, picture on the left, in 1987, and on the right is where we currently are. 2009 we added the European Technology Centre on the front. We've expanded out the back to create some space for our more large machining, which we just invested in several new machine tools in that area a couple of years ago. There are plans to expand into this little empty square at the back, and once we expand there, we're a bit full because there's a canal runs along the back, so we're going to invest in some orange waders and just chuck them in the canal. They'll be alright. There's over 300 machines in our range. It's an enormous range that goes right from your very, very simple 2-axis lathe, 3-axis mill, through to 5-axis mills, 5-axis machining centres, 5-axis mill turns. We've got multi-spindle, multi-turret machine tools, and also laser processing machines, whether that be 2D on flat sheet or 3D. The range is enormous, so there's pretty much a machine tool in there to cover every eventuality you can think of. We do have a range of our own automation that we sell, and there's a couple of gantry type for the turning machines. More recently on the CV5, on the machine at centres, we've got the 6-axis robot on the turn assist, but usually they tend to be pallet transfer type automation. Our applications department is a large department. They are involved in pre-sale activities, whether that be doing time studies, feasibility studies, machine selection, tooling selection, work holding selection. They help our sales guy out with proposals in all of that area. Then should we be successful and win the order, they help out post-sale, and these guys will be the guys on the duck board who come out to various places of work, make sure the machines are performing to their full potential. We've got a wealth of knowledge in there. There's the engineers in that department are from lots of different disciplines, a big cross-section of industry sectors. There's a huge wealth of knowledge in there. We don't like to have a customer-supplier relationship. We much prefer a partnership, as we call it. We seem to think that it works much better, because generally customers know their product inside out, we know our machines inside out, and if we bring the two of them together, we tend to have a much better result rather than just, there's your machine, go and use it. So what do I manage? Not a lot, if you ask Graham, but anything that is more than just a machine sale. Anything that includes any work holding, any tooling, any automation, any support, right through to full turnkey projects would fall into the remit of the project. We've seen quite a steady increase over the last 10 years of the amount of projects that we've taken on. We think largely because of the lack of skill in the workplace, and a lot of them projects are now starting to include automation. Again, we think probably because of the lack of skill in the workplace and this need to be more efficient and get more utilisation out of the equipment that you're buying, because it's not cheap equipment. You need to make sure it's working to its full potential. And to do all of that, we have our project engineering centre, which is based in Worcester. This is very much the applications engineers guys. This is their playground, it's their Alton Towers, they love it. We've got overhead craneage in there, temperature control inspection with a 5-axis scanning CMM in there. The beauty of that place is the doors can be locked should our customers have confidential projects that we need to look at for them. We take them in there, we build them, prove them out, lock the doors, and then once it's shipped to customer, open the doors and nothing's ever happened. It's a superb facility to have. I want to concentrate a little on our Palletech range, which is a pallet transport type of automation. It's not a new concept. The concept's been around since around about 1980. The range that this covers is enormous. The machine tools that it covers is all of our horizontal range. It covers a lot of our 5-axis machining centre range, and the units themselves, they can be 1 level, they can be 2 level, as this one is here, they can be 3 level. So the range is massive, it's huge. The modular design of it allows it to be pretty much clicked together, much the same way as you would Lego. Clips together to meet whatever customer's requirements are, really. And because of the modular nature of it, it's also expandable within the field, which makes it an attractive option for customers who think their production needs are going to increase within the few years, but maybe not now. We can start off small, then expand to bigger as we go down the line. Now this product range that we had presented us with a host of challenges. First of all, if a customer is new to this idea of automation, it's difficult to explain what it does and how it works from a 2D drawing such as this. The other issue we had is Japan were producing our drones for us, so we've instantly got a time delay just because of the time difference between the UK and Japan. When I'm asleep, they're awake, and vice versa. Sometimes these modules can be difficult to explain. Again, from a 2D drawing, they can be very difficult to explain, especially with customers that aren't familiar with it. So explaining what they are, how they go together, what possibilities you've got from that, it's quite difficult for us. And quite often, our sales guys, bless them, they can't know everything, can they? Sometimes they'd request something that just isn't feasible. Purely through lack of knowledge, they request something that isn't feasible. And then, as always happens, the customer receives this layout and he says, actually, can we just move that over to the other side? Which, yes, we can, but our time delay kicks in, and we've just lost another week before we even think about it. So we decided we needed to do something about it, and we started looking around for something to help us with that, some software to do that, and quickly realised that there wasn't a great lot on the market that could do everything that we want. So we started around about 3 years ago talking to Miko and his team, who again said, no, we can't really do that, but we'll have a go, and we'll see if we can. Now, Samuel has already touched on it. The Open API was massive to us, because the library of commands that are available behind that API are absolutely enormous. It's huge. And one of the benefits for us was we were able to manipulate the software to do what we wanted, pretty much. Custom commands, get it to run the way we want it to run. Given that everything can have this Python script behind it, we're able to add interfaces to our models, to these modules, and we're able to make sure that they clip together, first of all, in the right place, or secondly, if it's not possible for them to clip together physically, they won't in the software world. It's intelligent enough to know that. And then we dropped into the statistical analysis again, which Samuel's touched on earlier on. We find that we've always been able to calculate utilization of our systems. It's nothing really new, but it was Excel spreadsheet, a little bit convoluted. We had to use average run times, average cycle times, average load times over a set period, which gave you an average figure, which in a lot of cases was good enough, but we wanted better. It was a little bit clunky, dare I say it. So with the ability to do this, again, Samuel's touched on, we can import our own CAD data, which we did, our own 3D models of these modules. We can add the intelligence to them so that these things just click together, just like Lego. And just like Lego, if it doesn't fit, it doesn't fit. It won't go. We get this lovely little green arrow that tells us, yep, I'm near something that I can clip to. Drop it in and it does. You don't get your green arrow, it don't go. We also had, our machine tools come with various different parts that can change. One of them being the tool changer. As the tool changer grows, the footprint of the machine obviously grows. And previously that would have, if that needed changing, that would have been a remodel. But again, because of the script that is able to run behind the scenes, in the models, we're able to put that just on a simple drop down. When you select your tool mag, there's no remodeling required at all. Same with various movable things, the swath conveyor. We can just have a checkbox to say move it to the out position. It allows us very quickly with limited skill to be able to put a layout together and make sure it works. Being able to add buttons through this Python API has been massive for us. A huge bugbear in my life was the maintenance area. We had a maintenance area to every layout, which just takes the extremities of whatever your layout is, adds a meter either side, draw a box. That's your maintenance area. It's really simple, but in AutoCAD you're drawing lines, you're constraining lines, you're trimming, you're extending. It's a good 20 minutes work to draw a box, and it's just my bugbear. I hated it. So the guys from support, they gave us a hand and said, well, actually what you're doing, you're changing the input, which changes the output, but the bit in the middle is the same. Surely we can do something about that. All we need to do is look for the extremes, add X to it, draw a box. So these guys came up with a button to do that for us, and got me several days of my life back. Again, the automated generation of drawings using the templates and the bill of materials, it's all just time saving. We tend to think of automation as robots in factories, but my mindset has definitely changed since starting to use this software, and the software itself can be a form of automation. Let's take that job that's repetitive, it's boring, it's time consuming. Let's let the computer do it. It's much easier. So we're modelling in 3D. Because the 3D world knows what modules we've used, it can auto-generate bill of materials, shopping list for our salesman, so he's happy, he just goes down, ticks whatever boxes we tell him to. It makes his life easier. It's great. We can also export in 3D PDF, which again for us is fantastic, because if you're sending any kind of 3D model data, you've got the issues of your intellectual property being out there, you've got the issues of export control. But because it's a 3D PDF, it's an Adobe format, it's done, really. Customers don't need any software to use it, just the bog standard Adobe Reader, which is on everybody's PC, I think. They can open it up, have a look around. And also the 3D images that we're getting out of the software, it's superb. We've gone from, as I say, 2D drawings to 3D PDFs, 3D images of what you're going to get. And they say a picture speaks 1,000 words. I believe it does in this instance. Now, because we're using it predominantly at the moment as a pre-sale tool, it's quite hard to quantify as a measurable. It's quite hard to say the benefit that we've got from it. But one thing I can quantify is time. Because previously, going backwards and forwards to Japan, making changes, doing this, that and the other, we were looking at around about 4 days to turn a proposal around for a Palletech system. And currently, we can probably fire one out in around about half an hour, including a coffee. Thanks to the ease of being able to clip it together and the automation that we've included within the software itself, just to make our life easier. Now the statistical side of things we didn't initially use, I'll be honest. We made it generally as a sales tool for producing images, for producing drawings. However, once we started to get into it and realised the power that there was behind that, we've probably taken over using the statistical side of it as opposed to the sales side now, to be fair. And as I said before, we've always been able to calculate efficiencies. We've always been able to calculate the top pie chart. It's nothing particularly new. But one that really is new or new to us and is extremely powerful for us is that we're able to plot what's happening against time now. So we're able to see what's happening, but more importantly we can see when it's happening. And in this particular case, we were feeding a Palletech system on demand. It was saying, I'm finished, come and feed me. So that's what we were doing. And our guy was busy for 10 minutes, he was not busy for about 40 minutes. And that was his day. And by the time he loaded it up, he walked away to go and do something else. He had a chat on the way. He never got to where he was going. So he turned back around because it was time to feed it again. So this guy's not much use. He's not a great lot of use at all. Now the ability to change things and re-simulate very, very fast prompted us to think, what if we don't feed this thing when it's demanding? What if we just leave it? What if we leave it alone and we only go and feed it when it's about to run out? Again, because we can plot against time, we know when it's about to run out. We can work that out. So that's what we did. We delayed this guy and we said, don't feed it on demand, feed it one component before it's going to run out. And that had the result on his actions being he was busy for an hour and then not busy for 3. He was busy for an hour, then not busy for 3. So that turned him back into a really useful guy. He's much more useful for 3 hours every 4 than he is for 40 minutes every hour. Much more useful. So we've started using the statistical analysis of the software an awful lot more. Now as well as your 3D images, Samuli's already presented some, we use quite a lot of video. And this is our process of putting a Palletech system together now. It is in real time as well. I've skipped a couple of steps, but it is in real time. We can change our machine without any remodelling. Take a copy of it and drop it into the next slot. And my favourite, my maintenance area. I've really got a bee in my bonnet about this maintenance area. We select what we want to surround, click the button, do it. Drawing generation, as I say, nothing's sped up, that is real time. We can stick our dimensions on, as many as we like. Get our bill of materials, keep our salesman happy. And we can spit out video to show our customer. We can explain how it's going to work from the 3D, or it's much, much easier, and I prefer it much more. Stick a video on and just keep quiet. That's how it's going to work. That's what it's going to do. And we can drop your components in. And often we're not dealing with engineers. We're quite often dealing with finance people. We're quite often dealing with business owners who don't particularly know about this kind of stuff. They don't need to. Why do they? But it explains what they're buying, it explains what they're spending their money on very, very easily, very efficiently. Now we were, as a company, as a department, we were pretty happy with that. But we're engineers, so we're never truly happy, we're just less miserable. We thought, how can the graphics and the statistics from that, they're pretty good. But they're still graphs and pie charts. They're still graphs and pie charts. If we're dealing with these finance peoples, if we're dealing with the MD who isn't interested, doesn't want to know, he just wants to know, is it going to work and is it going to make me any money? We thought, you really can't go wrong with red, amber, green, can you? I can throw a rag chart up there and everybody in this room knows what it's about instantly. So we thought, why don't we use a little bit more intelligence, let's colour code our pallets. Let's make them red if they're not loaded, green if they're loaded, amber if they're not. Amber if they're being machined and need servicing. Additionally on that, we thought we can stick these statistics as a bar chart on the 3D world. You can see it in real time. It's great. And with the introduction of the assemblies, which I was struggling to find which version, but somebody's very kindly reminded me it's 4.3. The introduction of assemblies in version 4.3 was another huge step for us, because what that allowed us to do was to put a specific job on a specific pallet, or more importantly in a specific place on that pallet. We can put several jobs on the same pallet, so we could load this thing up with as many jobs as you like. And where we used to have to work on average cycle times, average load times to try and get any statistics from, we don't anymore. Each component can have its specific load time, specific run time, and what that allows us to do is we can analyse said system, see how it's performing, and in some cases we needn't even have any additional hardware to make things better. We can see the effects of just tinkering with a schedule. What if we do this job first instead of that job first? What'll happen? And we have the ability to do that really quickly and simulate really quickly and get some actual data to prove that. And again, we can produce video from that with customers' actual parts in. And as we can see, we start off quite red, but as we run, our red slowly diminishes, our green gets better. But there's people that haven't got a clue what this does, but it's starting to turn green, so it must be good. Again, the use of the assemblies allowed us to put, as I say, different jobs anywhere we want them really, all with different load times, all with different run times. I'm not a big fan of statistics, but I'm going to dive into a few. The bar chart on the left is robot density in the manufacturing industry worldwide. The UK isn't on there because we're hopeless. We're over here in this guy's teeth somewhere. The lead is Singapore, are 918 units per 10,000 employees. The UK at the minute, the UK in 2017 was down to 85, which is nowhere near. We had a bit of a spurt between 17 and 20. We jumped at 18% and we were up to 101 units. Then COVID hit, and COVID hit everybody hard, didn't it? So we haven't grown a great lot since then. Today, as of this morning, we were up to 111. The average across Europe is 126. And quite a shocking one. The UK is the only G7 country that is below average. So we're not very good at it. And the people in this very building, this is an MTC report, that quite clearly tell us automation is the key to UK productivity. And I firmly believe it is. How many people, has anybody in the room got Hive heating on their phone? It's got to be. 1, 2, any more? Hive heating. Yeah, heating control on your phone. 2 out of what? Probably 25. It's great, isn't it? I mean, I can look, I'm 300 miles from home and I can turn my heating down because my missus has got it too hot. Send her a text message to put a jumper on. But I think it's a bit mad really that there's more of us in this room, percentage-wise, using automation in our own home than there is in factories and manufacturing throughout the UK. As a result of which, we thought, we quite like this software. What can we do apart from our Palletech system with it? Can it do anything else? Which these guys knew it could, but we didn't. So we did a bit of learning. And we're starting to use it much more and more. As I said earlier on, our projects are increasing, and the projects that contain automation are increasing even further. I think the UK is starting to take on board that we need to automate, we need to do something about this. So we're using visual components, again as Sam already touched on earlier on, in the first instance very quick and dirty. Throw some components in, will the robot reach, will it do what we think it'll do? Yes. Let's carry on. And it's very easy, again, just through the use of 3D, through the use of 3D PDFs, it's very, very easy to convey that idea to customers rather than trying to explain over 2D drawings. We can show them. We've even in some cases used it with no automation, none at all, just to see if our man can keep up with machines. Can our man physically load them machines fast enough? Just because of the statistical reporting in the software, it's ideal for that. And again, video. Well, we said earlier a picture speaks 1,000 words, but I think a video or a simulation, it speaks 1,000,000. It's really easy. We just put it on and be quiet. Another thing that we are seeing a huge benefit from is the use of VR. I mentioned we had our project engineering centre earlier on. We've modelled that up in 3D, and that allows us to drop whatever layout we may come up with. We can drop it in there. And again, for people that aren't aware of what they're buying, maybe the finance people, maybe the AMD, it gives you a good idea of scale, because we can take them to that place physically and say, this is our PEC, and then there you go, there's a headset, you're in the virtual one with your layout in it, have a walk around. The benefits of the VR as well are silly things that you don't see and you don't pick up on. Our walkways big enough? Is this accessible? Because sometimes the distances that are in your head are not quite right when you get into real life, are they? We're finding a lot of advantages from that. So what's next for us? And my answer is, I'm afraid I haven't got a clue. I don't know. Don't know what's next. And my reason for that is yet more statistics. For somebody who doesn't like statistics, I'm using them a lot, aren't I? 65% of today's children won't be employed in jobs will be employed in jobs that don't yet exist. And my first thought was, my job might not exist in 5 years' time. I think Graham might argue it doesn't exist now, but it's a different matter, isn't it? And then I thought, what if we're trying to recruit engineers as we know them as today? We're already struggling. So in 5 years, if we're going to be limited to 35% of the job market, because these other 65 are doing something else, we're only struggling even more, aren't we? So I think we need to continue. I'm very fortunate in that I work for a very forward-thinking company. We're always looking, what's next? What can we do? And again, back to this partnership. We like a partnership with our customers and our suppliers, because it's driving forward change and progress, isn't it? Back in 2019 we celebrated 100 years of Mazak, and our slogan for that was Together Success. So that's not just a Worcester thing, that is a worldwide ethos driven by Japan. We want to work together with our suppliers, with our customers, and hopefully with Visual Components, and see what we come up with next. Continually push each other, challenge each other, I think is the correct term. Visual Component support might not see me as a challenge, but so I think going forward, I think there's a lot of exciting times ahead, to be fair. I think there's a long way to go, because we don't particularly know the impact of digital twins on artificial intelligence within our industry. I'm very much looking forward to this afternoon to hear about virtual commissioning, because a lot of our customers, if we get this far with them, they are, yes, we like that idea, it's great, it's fantastic, but in order to put your kit in, I need to take my kit out. So you can only have my shop floor for a month. So if we can virtually commission something and bring that time, that dead time down, it's a massive advantage for us. So I'm very much looking forward to hearing what people have to say this afternoon. And on that note, I think everybody's probably ready for a coffee now.